Before we can truly understand the idea behind what constitutes a collision domain, we need to first of all understand what a collision is, and we also need to understand the impact that it may have if we have a collision in our infrastructure. Now, what I want you guys to do is I want you to envision that I have two hosts. So let's say host 1, and we'll have host 2. And these devices will be connected to one another via a single Ethernet segment. And what we're going to do is, just for the sake of our conversation, we're going to pretend that this is a single segment with just two devices on it. Now, we know that in order for these devices to communicate, they need layer 3 logical addressing. So let's go ahead and issue this guy an IP address of 10.1.0.1/24, and we'll give this guy a layer 3 address of 10.1.0.2/24. And looking at this, we can tell that these devices are both in the same network. We operate under the assumption that whatever we're doing down here is going to be a single segment. Now remember, we're talking about layer 1, and layer 1 has no concept of VLANs. I feel like I've kind of put the cart before the horse here in talking about VLANs, but I have to at least allude to them so that we can carry the significant parts of this conversation into this area over here. So these devices need to be able to talk to one another. And we already know, we've already talked about the fact and the way that this actually transpires, and that is that every one of these devices has a network card. So each one of these hosts has a network interface card that's integrated into the host itself. One or more. And at very minimum, each of these have a port, and that port is what is connected to this Ethernet segment that we're describing. Now, first of all, let's assume that I'm sitting here at host 2 and I have data that I want to be able to send. Well, the first thing that I'm going to do, one, is I'm going to listen to the segment. So I'm going to listen to the segment, see if anybody else is talking. And if no one else is talking, then what I can do is I can actually send my data onto the segment. Now, I want to talk about how we listen, how these network interface cards listen. So what I want you to do is I want you to imagine that every network card has electronic circuitry built into it that is going to allow me to be able to monitor the Ethernet segment for a voltage. We'll call this a voltage sensor, like a multimeter. Over here, same scenario. This host's network card is going to also have a meter that is going to allow me to be able to listen to the segment. What am I looking for? Well, if I'm sending ones and zeros, what ends up happening is I'm actually sending these ones and zeros by applying voltage. So if I want to send, what I do is I listen, which basically is going to translate to I'm going to determine whether or not there is voltage on the wire. If there's voltage on this wire, somebody else is talking. So I have to wait for that voltage to disappear before I can send. So what we'll do is we'll find ourselves looking at the situation here to where if I detect a voltage, I'm not going to transmit my data. If I do not detect a voltage, then obviously I can send it. And that works both ways. So when I'm sending, this switch right, or this device right here would see the signal and it would not send. So this is a process referred to as carrier sense multi-access capability. But the question becomes, well, what if I'm sitting over here and I have something to send, and Bob is sitting over here and he has something to send? We both listen to the segment and there's zero voltage. So we both think that we can send at the same time and we transmit the information that we want to send. That constitutes what we call a collision. And collisions are bad because what ends up happening is the information gets jumbled. Well, the question is that what we want to do is if that happens, we want to find out that it happened. And the way that we implement that is through a technology called collision detection. That's not the only solution there is. There's also collision avoidance that ran in some of the old school protocols like token ring, but we use Ethernet. And Ethernet is purely a collision detection mechanism. So you'll see this annotated as carrier sense multi-access collision detection as a mechanism, but that begs the question, and that is how do I know that there has been a collision? Well, it's part of our listening process. Even though we're sending, we never stop listening with regard to monitoring the voltage that's actually running on the physical media. So in this instance, if I were to just assign a value, let's just say 0.2 volts peak to peak. That's just a measurement of voltage. And let's say that a 0.2 volts peak to peak is the signal or the voltage that's on the circuit if someone is transmitting. So if I listen to that and I only see 0.2 volts peak to peak, and this is just an arbitrary number that I whipped out just so that I can have something to speak to, I know that a device is talking. Well, the thing that you also need to understand is that voltage is additive. So if I'm sending, I'm putting 0.2 volts peak to peak on the circuit, and if Bob is sending, he's putting 0.2 volts peak to peak on the circuit, which means actually what we would do is we would see 0.4 volts peak to peak in the case of a collision. Actually, if we see anything greater than 0.2, 0.4 is greater than 0.2, then what we've done is we've detected a collision. So what we do is we have a red line here, and that red line is going to be anything greater than the norm is going to be part of this collision detection mechanism. And you have to take into account, like I said, hubs give me the capability of being able to add more devices to this segment. So it stands to reason that the more devices that I add to this segment, the greater the probability that I'm going to actually detect a collision, and it's also going to possibly take longer for me to be even able to send information onto the wire because other devices may actually seize the circuit before I get a chance to do anything with it. So what we see here is this idea of carrier sense multi-access collision detection and how it works for us in the beginning, but as our networks scale and get bigger and bigger and bigger, and remember we're talking about data center, which are some pretty huge environments, carrier sense multi-access collision detection is definitely not something that we want to rely on in order to be able to allow devices to send and receive information, which is one of the reasons that layer 1 devices like hubs went the way of the dodo. Even in enterprise, route switch, this is not the way that we want to do business. In fact, if I have a switch, it's important to know that every port on a switch equals a single collision domain. So if I have 100 devices connected to a switch, that means I have 100 collision domains simply based on the way the system operates. And that's what we're going to look at next. So when we come back in the next video, what we're going to do is we're going to talk about a process that allows me to be able to absorb collisions and proactively make certain that my environment is going to be as collision-free as possible. But keep in mind that in this environment, I have a single collision domain and I also have a single broadcast domain. The Ethernet segment constitutes a broadcast domain. So this means that if I send information, that information will be sent or could be sent everywhere on this segment. So we'll wrap this portion of our conversation up in the next video. I'm Terry Vinson, and I'd like to thank you for learning Data Center with me.